amplified pattern recognition.
Why does the universe exist? We're about 5 Einsteins away from the answer.
Welcome to Think Tank. This is a podcast where in each episode we pick a topic and then we discuss it with industry professionals and thought leaders in that industry. I'm Josh Gonzalez.
And I'm Braeden Drew. And we're your hosts of Think Tank. This is episode 8, where we'll be talking about machine learning with Nick Frosst.
Nick works on machine learning at Google, and he gave us a very interesting technical perspective on machine learning and AI.
We use some very technical terms, so if anything wasn't clear or you want to learn more, visit our website at thinktankcast.com and go to episode 8 and view the show notes, which will have some links to some of the things we talked about.
If you have any questions or comments on this episode, feel free to reach us out at thinktankcast on Twitter. Let's get right into it.
So why don't we start off by you just telling us a little bit about yourself and where you are in the AI space and machine learning.
I did an undergraduate in computer science and cognitive science. I've done some research in a couple of subfields of AI, including computational vision, where I was working on saliency prediction, and computational biology, where I was working on rare disease patient matching, as well as neural networks and machine learning kind of head on. I also did a little bit of research in the cognitive science department at U of T in neural networks and theories of consciousness and a couple other things. I worked at a startup for a little bit and a hedge fund as well for a little bit. And now I work at Google on machine learning and neural networks. Not on research, on application.
Oh, on actual application. So what do you do there at Google?
I work in ads shopping, in shopping ads.
Okay, cool.
Yeah.
So like using that same kind of research that you've done in the past with predictive analysis? Or is it more on a different kind of...
Nah, just general ML stuff, nothing.
Yeah.
Did you find a lot of the stuff you learned in your undergrad was transferable into your Google job?
I mean, I should hope so. Like,
let's hope
I think so, yeah.
So that was really good.
A lot of time.
Well, some people, they do their undergrad in like some random arts, like theology or something, and then they go and do something completely different. So.
Yeah. So, I mean, I guess like I took a bunch of philosophy courses, and those are not applicable like every day, but I mean, they're certainly still useful, I think. So
yeah, especially the way you think about it, especially with AI. I mean, philosophical beliefs are probably like the driving factor in AI, because right now I don't know how much research there really is to actually predict anything. But if you think about like philosophy, like it's all about consciousness, and I'm sure like that's what you're trying to achieve when you're trying to build AI.
Well, I think I disagree with you.
Okay.
There was a time when philosophy was hugely important to the study of AI. There's this professor at U of T called Brian Canwell-Smith. He's a great guy. And at one point I was listening to, I forget where he said this, but he was talking about how he was at MIT like in the 70s when the beginnings of like computational AI were like starting to happen. And he was talking about how, like, across the street from their research lab or something, there was a synagogue, and how they would, like, joke amongst themselves about going to, like, put a computer at the altar at the front of this place.
Wow.
Because they felt a religious connection to the process of creating intelligence. I mean, they joked about it, but they were apparently, according to him, they were feeling that this was somehow true. And there is lots of, like, in the Abrahamic tradition, there is this like notion of like God created man, and God created man in God's image, and so man should be able to create man should be able to create something else in the same way that God created us. And there's like there's a story of like the golem and like this so there's this idea, and they were joking around it at the time, and we don't have that anymore. Nobody really like if you go into the AI labs today, like talking about that as much, and I think that's because they're getting success without having to talk about that philosophy.
So more technological at this point.
Well, yeah, like at this point you can go in and without thinking about philosophy or thinking about anything, you do really sweet. Also, am I allowed to swear on this?
Yeah.
Okay, yeah. You can do really fucking cool shit.
Oh, yeah.
With with machine learning without thinking about that stuff.
Totally.
And you can get really cool results.
Would you say most AI applications are very like single serving? Like, here's a problem, we're going to generate AI to solve that problem? Or is it like the way like the ideology and the philosophy behind it was like AI is all encompassing and it's organic basically, but the AI that you're talking about, you don't really need Like you don't need a car.
Recreating the human brain, essentially,
Yeah.
is what you're getting at. Like
Yeah.
the full, like, holistic approach of it.
Like most of the stuff you're working on is just like, can we predict words that people are going to use on their phone or what they're
Yeah.
going to search? Like you don't want to have.
But that's machine learning versus AI. Like, what's the difference between the two? Because I know there is a vast difference between the two.
There's many more people who will say I study ML or I work in machine learning than there are people who will say I work in AI or I study AI.
Would you think that's because of like the stereotypical movie portrayed version of AI? So whenever you tell somebody, "Oh, I work in AI,"
yeah,
and
they think all these
Ex Machina,
yeah,
Transcendence, yeah.
yeah. But in terms of the difference, like I really do think that machine learning is a promising candidate for artificial intelligence.
Okay.
So is there a difference? Maybe not. Like maybe it'll turn out that AI can be done with ML.
Okay.
In which case, like, yeah, then there won't be a difference. But in the meantime, yeah, like the two words have very different meanings in everyday use, and I think there aren't many, and I don't know why there aren't many people who will say that. Maybe it's because, like, again, we kind of lost the philosophical religious thing with it. Maybe it's because we've been like burned too many times. Like, I'm sure you've heard people talk about like the AI winters and stuff like. Yeah, like there have been moments where people have been like, oh, like never mind, like it wasn't going to work then, it's not going to work now. We undoubtedly have virtual reality now, right? You can put on headsets. It is a virtual reality. It's not a great one, but we have it, right? That can't be said about when we're going to have that. Like, it's not as you can't measure when we have AI.
So it's not like one breakthrough thing. It's gonna be like, okay, well, this happened, this crazy breakthrough happened. Now we have AI. Is it like a path?
Yeah,
What's
it's
the stepping
well, I
stones?
mean, something I've talked I think about a fair bit is like the shifting goal line or the shifting bar for AI. Mm-hmm. You ever heard of the Mechanical Turk?
No.
Okay, so the Mechanical Turk was this thing that happened in like this is why I got a bad memory, so I forget this, but I'm pretty sure it happened in like the 1800s.
Okay.
Mechanical Turk. It was this clockwork machine that was said to play chess. Okay.
Oh no, I do know.
You have heard of this?
Yes, yes.
Yeah. And so the basic idea was like there was this like chessboard with this humanoid clockwork thing. There would be like pressure plates on the chessboard, and so when you put a piece down, you were supposed to believe that somehow it would like calculate the next best move, and then it would pick up the piece and do the next one. This really caught people's attention because in England it was popular. I think there was even a couple presidents who ended up playing against this thing because it was a big deal. People were really excited about it, and they were excited about it because they thought like they were all like gung-ho about the Industrial Revolution or whatever, and they're like, if we can make this clockwork thing, like if we can make it play chess, like that's pretty goddamn close to AI. Like that was something that would convince people that what they had done was really quite incredible. Now, of course, it turned out to not be a clockwork machine, but just a guy sitting under there playing chess. But it's important to note that at that time, someone thought, look, what's the best prank I can play on people about getting a machine to act like a person, and they said chess.
Why chess? Because that's always like every time we see in the headlines, like, oh, a computer beat this kid in chess. Oh, computer just beat the best chess player.
Yeah, well, because that happened like more than a decade ago at this point, and like we don't care any longer.
Right.
But at the time, they really would, and there was a long time where people said, oh, if we could get a computer to play chess, like that would be AI, and then we beat it, and it wasn't AI.
Oh yeah.
People, I think at the time were just defining what AI was, because it didn't exist in any form. And I was reading a paper, and they're talking about why chess was such a big focal point, and because chess was seen as like an academics game, like a normal human can't do well at chess.
Yeah.
So if you can create an entity or something human made that can beat the best people in the world at chess, like that was supposed to mean like the machine was smarter than them.
Yeah.
But that was because their definition of AI was, could a machine do something better than a human? And machines can do a lot of stuff better than a human. It doesn't mean it's artificial intelligence.
Yeah.
Because it wasn't all-encompassing, like, is it like a human brain? If I showed it the color green while we were playing chess and it was a pencil, could it describe that to me? No. It can only play chess. It can't.
So it's
do
like
all
single
those
use
things.
case AI, where like it just plays chess, or there's just AIs.
Like that article you showed us that we were reading. I can't believe I can't remember.
Oh yeah, from like
It
but why was that the? Have you seen those article, the AI revolution on waitbutwhy.com?
No.
It was just him. He was separating AI into different tiers. So basically, there's general AI, machine learning level AI, which is like what we have, and then it's weird. They call it like super AI, which is like utopian future source of what artificial intelligence is going to be. Like right now, AI is very singular. If you want to build kind of like an organic algorithm and calculations in a machine, it can only really do one specific task really, really well. So if you have a machine that can beat somebody in chess, which they do now, you can't have that same machine interpret speech or colors or anything like that.
I mean, you can kind of do that at this point. I mean, the topical thing about this is AlphaGo, right, which was a neural network program which just beat Go, and like the strategies they used for that. I mean, it's a different network, but it's still a neural network, and that neural networks have proven to be really useful in a wide range of like so many different problem spaces.
What are some like applications of neural networks? Like just to name off a few.
Neural networks are great. Some practical applications: speech synthesis, image recognition, speech to text,
that crazy robot that they had on Jeopardy.
Watson.
Oh, he used that. Yeah.
Really? Okay, so that was. Yeah, you're right. It is.
No. I don't. I think
it wasn't neural network at that time?
I think they. I'm not
because it had to recognize Alex Trebek's speech. That was like.
Okay. So that's
what I was.
Yeah,
it was still tapping into the internet and just typing in the questions.
Yeah. Okay. Good. Yeah. So that the speech recognition
it didn't actually
would have been neural
know
networks.
Those, answers. It was just finding them. It was more like a search engine that could recognize his speech.
Yeah. Yeah, Watson was interesting.
I think is that an example of a neural network, or is that just totally different?
Well, wasn't on the Watson team. I'm not entirely sure what they're using. I have like a general understanding, and I would imagine that their speech synthesis was neural networks, simply because there's nothing else that's succeeding in speech synthesis the way neural networks are.
Not as well as
So is
Watson
that like
was.
Siri, Google Now using that as well?
Like all of that, yeah.
Okay.
So pretty much any time, like a rule of thumb for when neural networks are going to succeed. If you have a whole bunch of data, and there's a relationship between that data and some desired output, but there's like structure to it, but you wouldn't know how to begin to write the program to make the connection between the data and the desired output. So like the canonical example is like the MNIST digit data set, which is a big data set of hand-drawn digits between 0 and 9, and every one of those things is labeled with the appropriate number that the person has drawn. So you look at this, and it's actually like challenging for a person. Like people draw the craziest numbers, and that data set's used constantly as like if you want to try a new learning algorithm, you try it on this data set because it's really great for lots of these things. And we could not really get good results on this before machine learning. There's other algorithms that do pretty well on it without neural networks, but neural networks are the best at this point. And that's because there's this huge data set. It's a structured data set. It has labeled data, which is really helpful. And it's the relationship between a 1 and what someone has drawn and a 1.
Hand-drawn 1 and a hand-drawn 5.
Yeah, is a very complicated relationship.
Yeah, that's very hard.
Yeah, and it requires like multiple levels of abstraction. So you have to be able to say first that's an edge, and then these two edges together they make like a line, and then this line in relation to this other line makes like a kind of like cross shape, and then that
means it's a 5. Yeah, and what does 5 mean?
Yeah.
Yeah.
And then that's the next step. Okay, it's a 5, but what does 5 mean? And do they have to know the meaning of it, or does it not matter? It's just taking in the number 5.
What he's hinting on is in the article where it was talking about machine learning has gotten proficiently better as time goes on to be able to recognize numbers and stuff that are handwritten or appear differently in text or in different languages. So it can appear, it can see a word, it can see a sentence, it can see all that data.
I think
but if you put them all together, does it understand what it means? So if I said 1994 and it was on there, and then I was like, that's my birthday, but the machine would never know that. It would just know that that's a number.
And would it even know if it's a year? It would just say it's a number? Would it be like, okay, 1994, that was a year?
And that, I know what you're saying about the abstract is it has to deal with the different inconsistencies in people's writing, and it's not like normal text. It's not code. It's not broken down into ones and zeros like it is on your computer or Microsoft Word.
Yeah, a better example is like photographs. I would say so because as a human, we can see a photo of a car. We're like, okay, that's a car. That's a Nissan.
Yeah, so we're really good at that at this point with neural networks. We can take a picture of a car and we can say that's a Nissan. We're excellent at that.
Right.
We have there's really great neural networks which classify images.
Can the same neural network say that's a Nissan in New York City on a sunny day?
Yeah, so there's even really great neural networks that take in an image and output a couple of sentences describing it.
Wow.
And they're very good at that.
That's unreal.
Wow. Yeah.
I heard something, I don't know if you know anything about this. I hered CAPTCHA, when you it's like I am not a robot, you check it off and then it gives you click each image with a boat. I heard
Yeah.
that it takes that information from humans to use towards AI. So it'll be okay. Well, a human clicked that these 3 pictures were boats.
Yeah, people have. For instance, one of the things that was done a lot was CAPTCHA with. You'd see like 3 numbers, and those numbers were the like an address written on a house.
Yeah.
yeah, and that was used to generate a data set for training, for training neural networks.
Was it used for training? I also heard it was like for Google when they couldn't find or they couldn't input the number of the house based on the photographs that they had. So they just put them up on the internet for people to type in, and then they use that data to actually.
Yeah, I don't know. I don't know about that. Yeah.
Weird stuff like that. So it wasn't actually AI. It's just humans working for free on the internet.
Yeah.
So in the same article, I don't know why I don't know the name.
I'll send you this article after if you want.
You
to
should
read
read
it.
it.
I didn't know there was required reading.
No. It's just
it's just so we know we have
stuff.
stuff to bring to the table and we want your perspective on it. So in this article, they were talking about the future of what AI could be, and they said in order to get an all-encompassing AI and have everything like the neural networks connecting like an artificial brain, basically.
Yeah.
Because the more neural networks you have, the more it'll also look like an emulation of the brain because it has so many. So they're saying, is there a way for you to design a neural network where it actively learns and adds its own networks? So it's basically machine learning how to machine learning. So it's just building itself, basically.
I mean, one of the things we don't have right now is a network is a learning algorithm which dynamically sets network architecture. There isn't really a good algorithm for that. And maybe there will be at some point.
Are people trying it?
I'm sure there's people trying it.
Yeah, there has to be.
Yeah, but there hasn't been any. Like I'm not aware of any.
Would you say that would be the only place where you could have like a huge breakthrough? Because if it's building itself, then.
Well, sorry, it's not that it's building itself. It's that like right now, if you want to train a neural network, you have to say like, okay, here's the data set. Here's the input, and here's the desired output. Let's make a network that has 5 layers. Those layers are using like rectified linear units. Like those layers are convolutional network, like whatever. They're like recurrent neural networks. You have to describe it. You have to say how many hidden neurons you're going to use, and then you tune all the weights. And really, you have to set a whole bunch of like a whole bunch of parameters. You have to set like the learning rate. You have to use what learning algorithm you're going to use. You have to decide whether or not you're going to do weight decay, dropout. Like there's all these things to figure out.
Right. So I think what we were kind of getting at was like the AI that would just do that. There'd be algorithms for AI to search for that itself, and basically AIs that would create on itself. That's what you're basically explaining, right?
Yeah. I mean, isn't
that where the exponential curve comes from? If it's always building itself, will it get to a point where it's super intelligent?
I think that's going back to more of the ideology, which I think has been lost.
Yeah,
as you're saying.
Yeah, because I think that's
because it's like if you can get to a point where something's self-aware and has its own conscious, like humans are. If we were created, if you believe in that, then we can create something else. Then couldn't it become conscious and then create something else? So if you created an AI, that basically all the AI does is deal with those funneling down the variables and writing its own algorithms, and it's setting in the layers. So it doesn't matter what it's working on; it just knows to go through those steps until it finds the best one that works. Then it moves on to the next problem. That's what I was bringing up. Like, if you could find something that could just continuously keep doing that, so it doesn't matter what you're working on. If you're doing picture recognition, color recognition, speech, where it'll just slowly keep going through that until it finds the best. Like the path of least resistance, like that's like the utopian view of AI. So they just set this thing in motion. That is all it does is just do that, but then the variables just change. So that's what changes its ability to process other outgoing, like external information. That's all it would do. If that was possible, it could keep building the layers, and keep going, and it has infinite like storage space in terms of what we care about on the planet. Because in China, they created that crazy super fast computer.
Was it the Bitcoin computer that's mining Bitcoins all the time?
I don't know. That would be hilarious if it was. But basically,
no, I know what you're getting
like
at.
This supercharged brain.
Okay, so I got.
It's basically building off itself.
I got to unpack a couple of things you just said because you just said a whole bunch of things. So I guess you're imagining is there going to be a point when we're going to have some like program running somewhere, and it's just going to iterate on itself and make itself better and better and better and better with no intervention, and suddenly it'll like emerge some like god from the machine,
right?
And like stand there and salute you.
Stand there and salute you.
I think that's a strange vision. I think it's a strange vision because, first of all, I don't know what the point is of that, and
You could ask it
Right.
anything.
And I also think that if we're going after artificial intelligence, right? Yeah. But it's just that the only model we have for intelligence right now is people, for the most part, and some animals.
Right.
Actually, in all animals, if you want to say there's a sliding scale of it. But
yes.
But what you have described is markedly different than you. That is not the way people work. That's not the way intelligence works. That's not like that as an idea is something other than artificial intelligence.
Basically, the AI that exceeds our own intelligence. I think that's
basically what they were doing is saying they're going to artificially create something that can speed up the rate at which evolution occurs in a technological form. So the way millions of years can pass through a human's like if you go back 10,000 years, we're building like fire. And then you come all the way now to here. So that's same hardware, same everything, even if you go back.
Yeah.
Well, it's evolving. It's just saying that it's like rapidly evolving.
So the way that we evolved over that time span, the computer's doing the exact same thing, but it can do it faster, stronger, better.
Yeah. So there are people who work on genetic algorithms with limited success so far. And it's interesting that we haven't had much success with genetic algorithms. Sorry, to get back to all of this, is that the idea that like we'll just write a program and then we'll let that program iterate on itself and it'll create some god is a weird idea. Like maybe it'll happen, but it's important to note that that isn't the way that we behave, and that the way that we behave isn't more like the way that we came about and all life on Earth came about is very complicated and unlikely and not something you can get by just randomly changing code.
So as someone who's a part of machine learning and you're in that whole atmosphere, would you say most people like they disbanded with that very old like theology view of AI and they switched over to calling it more machine learning, so it's more like just a really cool but more complex tool that you have just to aid in like very similar.
It's more industrial.
Yeah, I don't think like when I think of my favorite ML researchers, lots of them think about philosophy and think about those things for sure. But at the end of the day, if they think they're creating if they think they're having like a religious experience with the process of creating intelligence, they keep that to themselves. For the most part, it is people like pushing learning algorithms and trying new things and exploring that space. I am a person now who works on getting people to click on ads. I think it's an interesting problem. I mean, I don't think it's that interesting.
And it's not even in an evil sense, right? You're not like, they need to buy this stuff.
No. No, I don't think there's anything.
No, definitely not. But it's also very interesting. Like, why do people click certain ads, and why do people not? So is that what have you found so far? Like, what is it that people
Tell
actually
me
click?
all your AI knowledge.
What do you want to tell you?
Like, how is AI even used in that kind of situation?
Well, okay, but again, see, we started the conversation of talking about the difference between AI and ML, and you've started using AI.
Right.
It's still
ML.
Well, I mean,
it depends.
It depends where you.
It's your perspective.
It depends what you're talking about.
Okay, let's say car ads. ML for car ads. Just talk
one
about
one interesting property about training a neural network on something is that there seems to be this opponent process between how accurate the model is and how much insight you can get out of it.
Okay.
So there seems to be this thing that the better this model is at predicting the desire, like at getting the desired output, the harder it is for you to tell why it is behaving this way. So a neural network is very strange because you'll give it this input and it'll give you an output, and then someone says like, why did it give you that output? And you have to say like, well,
it just did.
There's like, you could try to, like, you could look at the hidden layers and you could be like, like this neuron lit up because of these things, so that looks like an edge detector. And then this one is like combining the output of those edge detectors, so that looks a little bit like a line, I guess. And then this one, like, you can do that. But the minute you start to get more than like a couple of hidden layers, that gets harder and harder and harder. So saying like you know, you're training ML on getting someone to click an ad, and then you want to say like, well, you know, what did we learn? Like, why did they click that ad? And you're like, I mean, I don't really know. And that's not really important. Like, you can kind of just say, oh, the model seems to be getting good results, so let's keep it.
Right. So what you're basically saying is most of the machine learning now is just trial and error, and then the ones that are working, you just keep implementing. And is the neural network loosely based off the brain and how neurons fire and react there, or is it just called that because it has some symbolism in the words, you think?
I mean, at this point, I'm going to say no. At this point, the name is almost deceptive. Don't get me, I mean, it's a vaguely neural structure, like what we have, where we have things that are either like 0, or we have neurons that are either 0 or 1.
On or off, yeah.
Yeah, and we have connections between those neurons to other neurons, and they have some output. But that is like just so simplified from the way our neurons work and our brain works that it's almost disingenuous to say that it takes like the sentence machine learning scientists are taking inspiration from the brain is like very buzzwordy and not particularly useful.
So it's not entirely true.
Just PR attraction.
Yeah,
you think?
PR. Yeah, I mean, there's just so many, like the way neurons are on neuron fibers, just so much more complicated. Don't get me wrong, there are people who are doing work on trying to take real inspiration from the way our neurons work and like simulate them as accurately as possible and seeing if you get cool behavior out of that. But also it's important to note that isn't what we're not. When people talk, just to get back to like AI again for a second, when people talk about AI, they're not talking about artificial brains. They're talking about artificial intelligence. And we make the assumption that intelligence is multiply realizable and medium independent. So we make the assumption that we can have intelligence on something that isn't a brain. And there's cool examples of this in the world. The one I like to bring up is squids.
Oh, right, yeah.
They would have said the worm. I thought that's what they...
The worm?
Yeah, worm. No, I think squids is a better example.
Yeah, squids are a
sure.
cool example because they broke off from us a long time ago, and they are intelligent in a way that is quite similar to us. In that you can like watch squids do some really really goddamn intelligent things, but they have a very different brain structure than we do. So they don't have a myelin sheath around their neurons. Sorry, not neurons. Around the dendrites. I get all these words.
It's either
confused.
axon or dendrite.
Yeah, it's because I'm a computer scientist, not
the axon.
Dendrites.
Yeah.
Dendrites. I don't know. The thing that connects one neuron to another. They don't have insulation around that.
That's a synapse.
No, synapse is the space between...
Yeah,
that's
synapse is
space
space.
between.
God, anyways, this is why I study computers. But they don't have that, right? So they have this structure that
Pretty sure it's
that
axon.
requires a
Is it
really
axon?
sparse. Yeah.
Okay.
They're like a really sparse network configuration, whereas we can have this really dense network because we can have all these things wrapped together and they're not like triggering each other. They don't have that. So they have a totally different brain structure and yet are intelligent in a similar way that we are intelligent. And that like is a pretty good evidence for the fact that what we call intelligence is not a property that's uniquely tied to brains, that we could have it on other things. So are neurons, like our neural networks inspired by the brain? I guess they're inspired by it. Are they a good representation? No. Does that matter? Like maybe not. Maybe not. Maybe
as long as you're getting that output.
Yeah, maybe it's fine. Maybe it's rich enough to get.
Everything you're saying, it just kind of like makes you think and gets the brain juices flowing. So, in terms of emulating a perfect AI in the way movie people depict it in sort of like a story, it's almost like they're defining intelligence in a very specific way that allows it to be replicated as like almost like an omnipotent god. But you don't need to be human and have a human brain to have intelligence.
So like the robots that people think that we'll have in our homes in like 50 years or whatever, like
iRobot.
robot butlers that look and feel like a human being.
Yeah, well, I mean, I don't talk about the look and feeling of it, simply because those things seem to be separate. Mm-hmm. Like I imagine, like for instance, we've had huge success in neural networks and in doing the types of things that we thought were going to be easy and turned out to be very complicated, like vision and speech synthesis and image recognition and stuff. And when we've had some success in robotics as well, but nowhere near the same level. Like if you watch, like the humanoid robots are still not very good.
Any ethics talks around about like just because you can do something, should you do it? Like
right now
is
every
everyone
episode.
Is anyone trying to do something?
So like right now it's super sexy for like smart and like famous people to come out and say things like, we gotta pay attention to AI before it gets ahead of us, you know?
Yeah.
And
exactly.
I think those people can shut the hell up. In that I just think it's just, don't get me wrong, like we definitely have to think about ethics. We should always think about ethics. And there's lots of interesting questions in there, but it seems a little over the top. It seems like to start saying things like we have to get ahead, like we have to start.
What does that even imply?
Yeah, it's just like
we need to put rules around it and regulations.
It just implies a richer understanding and a richer definition of all these things than we have. Like we don't even have a definition of what AI is, and someone wants to come around and start writing like regulations about it. We don't have a rigid definition, and it seems a little over the top. Yeah, so like there definitely are ethics conversations, but they're not about how do we treat the robot. how do we treat the
Do we
computer?
treat them
No,
like
no,
a
no.
human? Yeah, I know. That's kind
there
of weird.
There are ethics conversations in like we want to get this data set, but what's the? I think we were talking about CAPTCHA earlier, and I think there was an ethical conversation that came up about the fact that they had kind of been tricking people into doing this labeling work for them.
Yeah, it was
And
like human
yeah,
labor
that's
work
what
for
I was-
free. Yeah,
and so
there was a huge.
there was an and that's a great ethical conversation to have. And is that something we think is fair or not?
Is
like
it free data?
Yeah.
Is it free information?
yeah, and that kind of stuff we should definitely talk about. Should we talk about like what happened? Like, should we talk about do we extend the same rights that we extend to people to AI? It seems
They have to be
it's-
defined.
Right now, I don't even think we should be thinking about that. Well,
I mean,
maybe
we
think
can
about
think
it.
about it. It's cool to think about. I'm glad, and we can talk about it in
We
situations
should,
like
yeah.
this, and that's cool. I guess one of the things I think it's kind of important to note when we're so we're thinking like, okay, in the future, we're gonna have these things that are kind of like people, but not really like people. Should we extend rights and rights to them? Right? Like that's kind of the question. Mm-hmm. And like, there's a huge portion of history where we like had people that
Yeah,
were
we didn't-
people,
Other people.
and we didn't give rights to them. So like.
Yeah, it's pretty fucked up when you
I
think
think you
about
just
that.
gotta, like, time will tell. I think the
time
main
will
thing-
tell, yeah.
The main thing I was just trying to get at is you guys are really smart. You're working with some pretty cool stuff, and tools can be used for good or bad. And I just wanted to know, is there an open dialogue on ethics? And from what I'm getting from you, definitely everyone has an open mind to it, and it definitely comes up in conversations.
I mean, I think probably not. I mean, I feel like, just in terms of computer science in general, like, one of the things I think is interesting is that if you study computer engineering, you have to take an ethics course in Ontario, right? And I think in all of Canada.
You should.
Yeah.
Yeah, and you do not need to take an ethics course if you do computer science, and we end up in the same jobs. And that's because we have like it's definitely like there's professional grade engineering. You have the whole ring thing. You wear the whole weird
Yes.
jackets. You
Yeah.
do the whole thing, and you go through this ethics training, and you end up working side by side with people who have not taken the same ethics training. I mean, I guess it would be kind of cool to get people to take ethics training, but it would also be kind of cool to have everybody have like an ethics course in university.
Everybody.
Oh,
it doesn't
everyone.
matter what you're studying.
Yeah.
You should be ethical in whatever you're doing.
Yeah.
Whether you're writing code, building like a bridge,
Yeah.
or starting a business.
Yeah,
Like, they
so-
all have to take ethics courses.
So our ethics course is a good way of.
course
know.
even enough.
Yeah, I have no idea.
It's enough to make people think about it. And
the computer science field could certainly use more philosophy and more ethics, but that's because everything could use more philosophy and more ethics. That's because it's not. Yeah, it just seems like a good idea. But do we need to start talking? Like, we're not at a stage where we need to start talking about whether or not it is going to be ethical to have an AI do manual labor for its whole life. We're not there. We're not there yet. Maybe we can talk about it preemptively.
And will it have feelings anyways? It's like, oh, I hate doing this labor work. I could totally be an artist right now. Like, that's kind of strange to even think about, but it's hilarious. But at the same time, like, it's not the same.
Well,
as a human.
so the will it have feelings question is a question that comes up all the time.
Yeah.
Wouldn't you have to build that in? Have a separate sequence of codes that take in external data that relates?
feelings?
I feel like this could be a whole other
Like,
topic
how-
of conversation.
How could
within
you have
itself.
like not only just feel, but like feelings that you can get from looking at something, rather than just taking that input and being like, "This is what that picture is." Like, how does this picture?
Okay,
of
so it sees a
fuzzy
picture of a
cat
cat, and it's
Yeah.
like, this is a cute cat. I love this cat. Like,
it wouldn't have that. It would just be like, "This is a white cat."
Why do you think it wouldn't have that?
I'm not saying it wouldn't.
Because
I'm
you have
not
to
saying
code that in.
Well, okay. First of all, we're not coding anything anymore, right?
Okay,
No,
so we're talking
we're
about
making a neural network.
So
and
it
we're
has a
giving
neural.
it,
giving it
doesn't-
inputs
and getting
getting an output
we don't,
from that.
Yeah, we don't know how it works, and we don't really care.
Wait, so how does
we're
this?
not-
So you're thinking that's an input, and a set of outputs could be feeling based? Is that what you're saying?
Wait, would
okay.
that not be built within the neural network?
yeah.
I'm so confused at this point because, like, could you not add to the neural network at that point and bring that
and
in?
delete things in the neural network? If you don't understand how the neural network, you have inputs and outputs.
With everything in between, what can you add to that? Can you subtract to it? Can you be like, hey,
I don't think
we
you
should add
can,
this?
because the complexity that we're talking about would have so many layers.
But also just like this, you're coming at this with the assumption that like your feelings are fundamentally different from the rest of how you think, right?
Yeah.
That seems to be the implicit assumption here.
Well, I don't know. There's
direct
emotional
thoughts.
intelligence, right? There's
Yeah.
there's
Your
emotional
dir-
intelligence
yeah.
and regular intelligence.
No.
No?
No.
Or is that just a
They're all the same thing.
psychological buzzword?
That's just that's just a psychological buzzword.
Yeah.
For the most part. I mean, and that's because like people come around this. Oh, there's corporal intelligence and emotional intelligence.
Yeah,
It's all just intelligence.
the EI, right?
It's how you chop it
and
up.
that's a great way. That's a great heuristic for empathizing and empathizing with other people and understanding yourself. You do a test sometime and it says you're very emotionally intelligent, very corporal. That's a great way of getting insight into you. That isn't talking about the way you're. That isn't like
how you're actually empathizing.
No, I mean that's like we don't even know what intelligence is, let alone these subcategories of it. It seems to be that a lot of the interesting and like intelligent behavior that people have is very emotional. It'll come down to even the way you perceive, like even the really low level neural functions, like vision, may perhaps have a lot to do with how you're feeling about stuff, and your current state might influence that and might make it a lot better. Like so, one of the things that we have right now that machines do not have is we care about a couple of things, and care in like a kind of real sense. And the great example is food. For whatever reason, none of us really want to. Well, some people want to die, and that's that warrants talking about a lot. But most animals, for the most part, are doing things to actively stay alive.
Yeah,
we don't have machines that do
basic
that yet.
survival.
Yeah, and we don't have machines that do that yet.
And why would you need that?
It wouldn't need those.
There's
kind of
lots.
things.
There's lots of people who think that maybe you will need that for intelligence. But
Like
there is
energy, like getting like well, we talked about energy before.
Fear.
Would it be like what would be the basic needs?
I have no idea. Of what the computer is.
Theoretically, just what would be like the basic needs of an AI or like of machine?
How would you instill that into an AI if you wanted to completely?
No, not even
replicate
just like
organisms?
random. Let's just think about it. What would be like the basic needs of an AI? Like, would it be getting electricity as we want to get food?
Well, I mean, maybe, but first of all, I'm not sure it needs it. Like some
Yeah.
people think it does. I'm not sure it does. But there's some people who think that if we want it to be really intelligent and intelligent the way that we're intelligent, it's going to need to want things and want some really low level things. What is it going to want?
Wouldn't
I
it
don't
also
know.
have to be afraid of things?
I think fear may fall out of that.
Okay, yeah.
Yeah.
'cause
I mean-
you want things, and if you don't have the things that you want, then that's an element of fear.
So there's people like there's one thing is you talk about like let's build a robot and let's have that robot need to find batteries to live, and like there now it needs something, and maybe we'll see what happens there. But I mean this is too far gone at this. Like
Yeah,
this is
it's just worth theorizing.
yeah.
you know?
Well, what I'm trying to get at this point, for some people will be like, oh yeah, they can totally replicate the human brain in forms of AI in the next like 30 years. I'm just like, well, in order for them to do that, you have to have wants, fears, and it has to
Needs.
sleep. Like it's going to have to simulate.
I don't know if it needs.
It
to
doesn't
sleep.
need to sleep.
Yeah,
I
because
don't
our
think
brain
so.
and neurons still fire when we sleep. It has to have a change.
But we're biological, man. It's gonna be different.
I'm saying like when we sleep, our brain's still working. It's just working in a different way. The way you dream, the way you find. You know what I'm saying? It has a completely different element
well, yeah,
in terms
but
of
that isn't-
thought
yeah,
and
but-
sense of self.
Yeah, but that doesn't prove that we intelligence will need it.
Well, some people say in terms of dream theory and stuff like that, some of your greatest ideas and fruitions and the way you abstractly look at things can happen while you're sleeping.
Yeah,
So
I don't.
isn't that a form of intelligence and an element that you'd need to have intelligence?
Okay, so I'm going to say one thing, but then I'm going to say something else. And one thing I'm going to say is that there was a really sweet neural network algorithm called the wake sleep algorithm that Geoffrey Hinton pioneered.
That's cool.
And that involved training a network on labeled data, so it would take input and get output, and predict the output and fine tune all the parameters so that it was better at predicting that output. And then it would not look at the data that was given, and it would take one layer, and then it would push that up to like the network by one level, and then it would try to predict and fine tune the parameters so that the higher layer would accurately predict the bottom layer. Okay, and you did that like a bunch of times on all the different layers, and that was like the sleep portion of the wake sleep algorithm. So the wake portion is when we're training on labeled data, and the sleep portion is when we're training on the network itself, right?
Okay,
And that was successful. That was good. And so then he kind of casually threw out in that like, oh yeah, by the way, that's my new theory of dreaming. The new theory of dreaming is that we dream to distinguish between brain noise and like world noise. We dream so that we can understand the structure of our brain better, and then when we wake up, we're better at doing things like seeing and stuff like that. You can train neural networks that are very good without that algorithm.
I think just to wrap things up, let's bring it all back here with machine learning and try to stay on topic.
really
where
good
we're
tool.
at. Really good tool, but I just want to know like what are some like really hard problems that can be solved Like off the top of your head, like what are like the top 5, top 3 that you like? This application can be used to solve this problem.
Okay, so
what is machine learning?
the thing that
excel
machine learning has done for us is that when we started AI, we took for granted a lot of the things that we did, and we assumed they were going to be easy. So the things that we don't think about, like walking around, like seeing, like parsing speech, those really low-level things that everybody does, and that that donkeys do, that like that creatures do, we thought those were going to be easy. I don't know if this is true, but there's this like myth that like at some point at MIT in the 70s, somebody gave some undergraduate like the summer research problem of, solve computer vision, thinking it would take like 4 months to do. I don't know if that's true. It's a nice story. Maybe it happened.
And now it's a full industry.
Now it's a full industry, and we still haven't really we're gotten very good. Like neural networks are really great, and they've gotten a lot better in the past like couple of years. But we still haven't done it. And so like one of the neural networks and machine learning in general is really great at doing the things that we thought were going to be hard that turned out to be really easy. Sorry, the other way around. We thought we were going to be easy and turned out to be really hard. And I'd say that's like kind of the takeaway from it.
Awesome.
Gave us a gain perspective. Also, I realized we never really asked you, what is it like to work for Google?
Dude, just Google it.
If you enjoyed this talk and want to check out more, go to our website at thinktankcast.com and subscribe with your email so we can send you all of the latest episodes, news, and updates right to your inbox.
Also, on our website, there will be show notes for this episode, some links to the things that we talked about, and more detailed information on our guests. If you want to see the video of this episode, it'll be on our YouTube channel, which is also linked on our website.
And if you want to keep in touch, we're on social media. Check us out on Twitter, Instagram, Facebook. We're at ThinkTankCast on pretty much everything, so you can find us on the web. And all of these details, again, will be linked to our website at thinktankcast.com. Hope to hear from you guys soon.
Amplified pattern recognition.
Why does the universe exist?
What features therefore?
We're about 5 Einsteins away from obtaining answers.